Unit 5, Lesson 1. This lesson is the start of our last unit of this semester. So this unit builds on what we talked about with functions, but this more specifically talks about linear functions. So functions where when we graph them, it represents a line. So the first thing to understand linear functions is what's called rate of change or slope. So slope is a specific type of rate of change. You encounter rates of change every day when you're driving. Miles per hour is a rate of change. Miles per gallon is a rate of change. How fast you do something is a rate of change. So you encounter rates of change every day. Proportional reasoning is a very important thing to have to be successful in a lot of different areas in life. So we're going to talk about the definition of a rate of change and how to calculate it. So you can use ratios to show a relationship between changing quantities. That means quantities that change. Time is a really popular one. So vertical and horizontal change is what we're going to specifically look at. The rate of change of something shows the relationship between the two changing quantities. Your miles per hour shows how your miles are changing as time is changing. So when one quantity depends on the other, this is true. The rate of change is the change in the dependent variable over the change in the independent variable. What you're going to look at is the change. I'm going to use a Greek symbol, which I'm going to apologize for in advance. But this little triangle is the Greek symbol delta. And that means change. Okay? So this ratio I'm drawing here, this is the change in y over the change in x. Now I could have wrote the word change, but I just wanted to show you that. The change in y over the change in x. So finding the rate of change using a table shows this table showing the distance a band marches over time. Is this rate of change in distance with respect to time constant? So distance with respect to time. So the distance we march depends on the time that has passed. Is that rate of change constant, and what does it represent? So the two things we look at. Let's first look at how the time changes. From 1 minute to 2 minutes, we added 1 minute to the time. 2 to 3, we added 1 minute to the time. 3 to 4, we added 1 minute to the time. So in this table, the time is increasing at a constant rate of 1. The time is increasing. Okay. Now, when we look at the distance, 260 to 520 in feet. That means they traveled 260 feet. 520 to 780, they traveled another 260 feet. 780 to 1040, they traveled another 260 feet. So to calculate our rate of change in this situation, the rate of change is our change in distance change in feet over our change in time. Because the distance we travel depends on how much time has passed. So the way we could calculate this, we see that it's constant for distance, it's constant for time. The way I would calculate this rate of change is I would take the difference of two distances. So I would take something like 520 minus 260. And then I would take the corresponding times. After 2 minutes, we travel 520 feet. After 1 minute, we travel 260 feet. So that means we travel 260 feet every 1 minute. Okay? So that's our rate of change. It is constant because our distance is changing by a constant value. Our time is changing by a constant value. So this 260 over 1, what this represents, it means the band travels 260 feet every 1 minute, every minute. Okay? So a rate of change tells you how one quantity is changing with respect to another. So how distance is changing with respect to time. So that's an application of it. Now, finding the slope using a graph, the rate of change. This is going to require us to use some points. So I'm going to use a different color for this, just to mark my points. So we've got to know how to name these coordinates, or how to handle these coordinates. So the first coordinate, first ordered pair, is the point -3, +1, okay? The other point is the point 2, 3. So to find the rate of change, we would find the change in y over the change in x. And we always read this left to right. So for the change in y, it goes from a y value of 1 to a y value of 3. So the difference of that is 3 minus 1. Our x values go from -3 to +2. So I would take 2 minus -3 to find those differences, or to find that difference. So this would be a difference of 2 over 2 minus -3 is 5. So that's a mathematical way of finding it. If you have a graph, you can simply just count. The change in y, we went up 1, 2. Up 2. Right, 1, 2, 3, 4, 5. So the change in y is +2. The change in x is +5. And you notice how I went left to right to get my rate of change, to get my slope. So a graph, you can simply just count. I'm going to show you mathematically how to find it using this. This doesn't have to make sense right now, but it will in a minute. And that's the slope formula. And I made a little mistake here. This x1, y1, it should look like this. It should be x. We call that a subscript, where it's kind of below the x, below the y. So that means x1, y1, and this thing in the middle is a comma. So x1, y1, x2, y2. x1, y1 is the point on the left, x2, y2 is the point on the right. So we take y2 minus y1 over x2 minus x1 to find the slope, as long as the bottom of that ratio is not 0. So in this diagram, it shows the coordinates of both the points. To find the slope, we use the slope formula. So the x-coordinate you use first must belong to the same ordered pair as the y-coordinate you use first. So I'll show that in example 3. So if we think of this as, x1 is x1, 3 is y1, we take the y values and subtract them on the top, y2 minus y1, x2 minus x1 on the bottom. So in this case, y2 is -1. y1 is 3. So -1 minus 3 on the top. Now to help me with x2 and y2 are part of the same ordered pair. So 4 would be right first on the bottom. x2. x1 is just 1. Comes from the same ordered pair as y1. So this becomes -4 over 3. That is my slope. If that can be simplified, I will simplify that. But this can't be simplified, so I'm going to leave it as a fraction. I don't want you to write -1.3 repeating. Ooh, that was terrible. Not that. I want the fraction. Fractions are going to be very helpful with slope and graphing later on in this unit. So that's why I want you to keep it as a fraction. In example 4, finding slopes of horizontal and vertical lines. We're going to talk about that, and the bottom has a nice little diagram to help you keep that straight. So we're going to do the same thing. y2 minus y1. So that would be 2 minus 2. x2 minus x1. let's use green for that. x2, 2 minus x1, which is -3. So in the end, what this becomes is 2 minus 2 is 0. 2 minus -3 is 5. So this slope is 0. And that sounds weird, a slope of 0. So a slope of 0 represents a horizontal line. A horizontal line looks like this. Left to right. It has 0 rise to it. It doesn't go up or down. It's just constant, okay? That's a horizontal line, right? So a lot of times they talk about rise over run. I don't always use that, but if you're thinking about rise over run, this line has 0 rise, but infinite run. So it doesn't rise at all. It doesn't rise or fall. It's just flat. For part B, same process. y2, -2, minus y1, 1. x2, -2, minus x1, -2. So this becomes -3 over 0, which, if you try this in your calculator, it's going to give you some error. This is what we call an undefined slope. You cannot divide by 0. So what this represents is a vertical line. So a vertical line looks like this. So really, when you think about it, with a horizontal line, the change in y is 0. The change in y is 0 for a horizontal line. For a vertical line, the change in x is 0. So you're thinking change in y over change in x. Change in y over change in x. So the change in x is 0 for a vertical line. That's why it goes straight up and down. So this helps us kind of keep those things straight, okay? So positive slope is a line that goes up from left to right. Negative slope goes down from left to right. Horizontal lines are just flat. Vertical lines go straight up and straight down. So those are the things I want you to know about slope. So you can move on to the practice, get some practice reading it from a table, a graph, and 2 points.